Okay, in this problem, the source supplies 40 kilowatts at a power factor of 0.9 lagging. The real and reactive losses of the transmission line feeder are 1.6 kilowatts and 2.1 kilovars respectively. Find the load voltage and the real and reactive power absorbed by the load. And really, we're going to utilize Telegin's theorem. We know the power supplied by the source. We know that it has to be dissipated or absorbed by the line in the load. So if we can calculate this, we can subtract the complex power there from the complex power supplied by the source, and that'll give us the power supplied by the load. And we know, for instance, that the complex power absorbed by the load is going to be VL IL conjugate, and I'm going to define IL here. So our task then will be to get in a position to calculate the complex power absorbed by the line, subtract it from the source power, and then use that to get the load power. And once we have that, we can calculate these other quantities. So let's start off with the complex power supplied by the source. We know the source supplies 40 kilowatts. We need kVA. So the magnitude of the complex power, the apparent power supplied by the source, is 40 divided by 0.9 at an angle of cosine inverse 0.9 kVA. Now the angle's positive, and the angle's positive because it's a lagging power factor. If the power factor had been leading, this would have been a negative angle. Okay, so the complex power supplied by the source then is 44.44 at an angle of 25.84 kVA. This is 40 plus J 19.37. Now we can calculate that current I sub L here. Not that we know we got the power, so S sub S is VS times IL conjugate, or IL conjugate is S sub S over VS conjugate. So we have 44.44 times 10 to the third, an angle of 25.84 divided by 440 at an angle of 0. That gives us, and we're really calculating IL, not IL conjugate. We're really calculating IL. That's going to give us 101 at an angle of minus 25.84 amps RMS. So now we know IL. And we can calculate R and X if we'd like. If we wanted to calculate R and X while we are calculating, for instance, we know that P of that line would be the magnitude of IL squared times R. So R would be the 1.6 kilowatts divided by 101 squared, which would be 0.157 ohms. And Q of the line would be the magnitude of IL squared times X. So X would be 2.1 kilovars divided by the 101 squared would be 0.2059 ohms. Okay, so we calculated R and X, or we demonstrated now. The load, the complex power for the load using Telegin's theorem is the source complex power minus the complex power absorbed by the line. So we've got 40 plus J 19.37 minus 1.6 plus J 2.1, which gives us 38.4 plus J 17.27, which is 42.1 at an angle of 24.22 kVA. Now, we know for the load that S sub L is VL times IL conjugate. So now VL is S sub L divided by IL conjugate. So we have 42.1 times 10 to the third at an angle of 24.22 divided by 101 at an angle of minus 25.84 conjugate. So then VL is 416.83 at an angle of minus 1.62 degrees volts RMS.